So this is the 40th session on rigid body kinematics. This is in continuation of the 39th video. In this video also I'll take up problems on rigid body kinematics for instantaneous center of rotation chapter. I'll discuss one more numerical similar to the one discussed in the previous video. Again, before going ahead, two things I have to say. First, that if you go through these videos properly, you don't have to go anywhere else, okay? And if you understand these videos and take a problem from any source, you'll be able to solve most of them. And if you have any difficulty you give it in the comment box, I'll clarify it, okay? And secondly, all these videos on rigid body kinematics have been placed in the playlist. So you can open that playlist and access all the videos, okay? I'll write down the problem here, alright, fine. I'll draw the diagram in which all the details are given, okay? So problem is this. This is a side view of a circular drum. C is the center of circular drum whose radius is R. This is a translating plank, okay? This moves at a speed v towards left with respect to ground. This is the plank. Center C moves leftward at a speed of 10v with respect to ground, and lowest point D1 of the drum, material point D1 of the drum, which is in contact with material point P1 of the plank, moves to the right at a speed of 2v with respect to ground. Okay, fine. This is the situation. And this is the side view of a rigid circular drum. C is the center, R is the radius. At a given instant, center C of drum moves towards left at a speed 10v with respect to ground. Lowest material point D1 of the drum moves to the right at a speed 2v with respect to ground. And material point P1 of the plank is in contact with point D1. And plank moves at a speed v towards left with respect to ground. Okay. Now what we have to do, we have to find two things. First, we have to locate the IC of drum with respect to ground by different methods. To locate the IC of the drum, with respect to ground by several methods. And second, to locate the IC of drum with respect to plank by several methods. Repeat everything same in the part A, but we have to locate IC of drum with respect to plank by several methods. In all cases, we have to give the distance of IC of the drum in terms of its distance from C. And we also have to specify whether it is above C, below C, to left of C, to right of C, wherever it is, we have to specify that, okay? So this is the side view of drum which is denoted by D. This is the side view of the plank which is denoted by P. And P1 is the material point of plank in contact with material point D1 of the drum. All the details have been given, the question has been specified. So first I will do what I will do. I'll write this A, B and B, okay? I'll take a part A. We have to locate the IC of drum with respect to ground by several different methods. Alright, fine. By several different methods. So now I draw the diagram here again. This is the drum. This is the center C of drum. This is the radius R of the drum. Center is moving towards left at a speed 10v. Material point D1 of the drum is moving to the right at a speed 2v. Okay. So from this you can see that the sense of rotation of drum is omega, anti-clockwise. Okay. Now I draw the line joining C and D1. Alright. See, in this case the IC of drum with respect to ground will lie between the points C and D1. As I have been explaining in the similar questions in the previous video also. And previous video also. This type of question has been discussed. I took the rod problem in the 38th video. There also similar concept was discussed. Rod problem, one was moving one direction, other end was moving other direction. Then IC of the drum will lie between the point C and D1. This can also be explained in another way. I'll explain it again. Suppose we take some point P here, okay? Suppose we take a point P here. Suppose distance of point P from center is y. Okay, fine. Now we apply SRC procedure for velocity between the point C and P. So SP arrow C, OP arrow P. I draw the line joining C and P. I give the speed of selected point C to other point P. So I give 10v to point P. Now omega is anti-clockwise. So P moves in anti-clockwise circle with center at C and radius y. So I give omega y to P rightward. Velocity of P is the vector sum of these two. So Vp becomes 10 v minus omega y. Now see, when y is 0, imply Vp equal to 10v left. And when y is equal to r, that is the point D1, Vd1 becomes 2v rightward. Now see, Vp equal to 10v minus omega y is a linear function of y. Alright, this is a linear function of y, and we know that linear function is a continuous function of y. So this is a continuous function of y. Now sine of Vp is positive, say, suppose we take the leftward direction to be positive. So at y equal to 0, Vp is positive. At y equal to r, Vp is negative. And in the interval 0 to capital R, Vp is a continuous function of y. And sine of Vp at y equal to 0 and y equal to r are different. So from intermediate value theorem of calculus, it follows that there exists a point P lying between C and D1 such that Vp becomes 0. And by definition, that is the IC. So IC of the rod will lie, of the drum with respect to ground, will lie between the point C and D1. Okay. So let this point P be the IC. Okay. Now we use the IC concept. Center C is at a distance of y from IC. The speed of center C is 10v, that is omega times y. Now D1 is at a distance of r minus y from IC point P. IC, that is point P. The speed of D1 will be omega into r minus y. Okay. Now what I do, I divide these two. 10v by 2v becomes 10 by 2, that is 5. That becomes y by r minus y. This becomes y equal to 5r minus 5y. 6y is equal to 5r. Y is equal to 5r by 6. One answer is obtained. IC of the drum is at a distance of 5r by 6 vertically below center C. This is the IC of drum with respect to ground. So this has been evaluated by method 1. Alright, fine. Now what I do, I evaluate this by method 2. Now this side a bit, okay. So I solve this by method 2. See, in method 1, I wrote down two equations, this and this. In method 2, what we do, first find omega of drum with respect to ground. See, when we are finding the IC of drum with respect to ground, all the velocities and angular velocities have to be taken with respect to ground. All the velocities are given with respect to ground, then nothing we have to do. But now by method 2, we have to find the omega of drum with respect to ground. Now omega of drum with respect to ground is equal to relative normal speed by separation of the line CD1. Now normal speed of C is 10v left and normal speed of D1 is 2v right. So relative normal speed between these 2 points is 10v plus 2v because they are in opposite directions. And separation between C and D1 is r. So this becomes 12v by r. Now what I do, I substitute this value of omega in any one of these two equations. Suppose I substitute omega in this one. What do we get? 10v equal to 12v by r into y. V cancels out. Y becomes 10r by 12. It becomes 5r by 6. Same answer we have obtained by method 2 also. Alright. Now we can solve it by method 3 also. By method 3 also we can solve it. How to solve by method 3? We use that IC concept. IC of drum with respect to ground is at a distance of VCG by omega along the direction omega cross VCG from C. Alright, fine. Now I write this one, okay? Fine. So IC of drum with respect to ground is at a distance of this much. So required distance y is equal to VCG by omega. VCG is how much? 10V. Omega we have found out to be how much? In method 1, method 2 we determined omega, that was 12V by R. 12V by R. So this becomes 10R by 12. That is 5R by 6. Along the direction of omega cross VCG. Now what is the direction of omega cross VCG? Direction of omega is sense of omega is anti-clockwise. So direction omega is dot, normally outward of the plane of the board. And VCG is leftward. VCG is leftward. Omega is normally outward. So omega cross VCG by right hand rule of cross product is in downward direction. So IC is at a distance of 5R by 6 in vertically downward direction from C. So same answer we have obtained again. Alright. So IC of drum with respect to ground is at a distance of 5R by 6 from C, center C, in vertically downward direction. In vertically downward what? Direction. Okay. In vertically downward direction. Fine. This is solved by method 3. Now I solve by method 4. Method 4 is this. IC of drum with respect to ground is at a distance of VD1G by omega from point D1 along the direction omega cross VD1G. Okay, fine. Now this one I rub it, okay? Now, how much is VD1G? 2V. So distance VD1G by omega becomes 2V by 12V by R. This becomes simply R by 6. Now along the direction of omega cross VD1G starting from D1. Now omega, direction omega is an anti-clockwise sense. Direction omega is dot, normally outward. And VD1G is rightward. So omega is outward, VD1G is rightward. So omega cross VD1G is in upward direction. So IC of drum is at a distance of R by 6 vertically above D1. That is at a distance of R minus R by 6 vertically below center C. So same answer we have obtained again. Okay. The same answer which we have obtained again. So I solved this part of the question by 4 different methods. I hope you have understood it. There is no doubt. In case you have some doubt, you put your doubt in the comment box. I will look into it and then clarify it. Fine. Alright. So this was the part A of the question. Now I solve the part B of the question. Fine. I solve part B of the question. In part B, what we have to do, we have to locate the IC of drum with respect to plank by several different methods. Okay. So again, I solve this by second method, by part B of the question. Now, when we have to locate the IC of drum with respect to plank, all the velocities and angular velocities have to be taken with respect to plank. So first what we do, we determine the speed of velocity of C and D1 of the material point C and D1 of the drum with respect to plank. That we have to do first. Now plank translates with respect to ground. So from the theory of translating frames, it follows that VCG is equal to VCP plus VPG. Here P denotes plank and G denotes ground. So velocity of C with respect to P is equal to VCG minus VPG. This is same as VCG plus reverse of VPG. Now VCG is what? 10V left. This VCG is 10V left. And this VPG is 2V right. So minus VPG, that is reverse of VPG, is also 2V left. And these two we have to add vectorially. From the theory of parallelogram law of vector addition, it follows that VCP is equal to 12V left. Okay. Now we also have to determine the value of VD1 with respect to plank, where D1 is the material point of drum in contact with the plank. So there we write it, VD1G is equal to VD1P plus VPG. Now this means VD1P is equal to VD1G minus VPG. Okay. Now VD1G is what? 2V rightward. This quantity VD1G is 2V rightward and VPG is V left. So minus this I'll write here. This becomes VD1G plus minus of VPG. Now VD1G is what? 2V rightward and VPG is V left. So minus VPG, that is reverse of VPG, is V right. Vectors of these two will be how much? Vectors of these two will be 3V right. This will be 3V right. So VD1P becomes 3V right, and VCP becomes I made a calculation mistake here. I'm very sorry, I made a calculation mistake here. See, I just clarified. VPG is V left. So minus VPG is V left. Minus VPG is V right. I made a calculation mistake here. I'm very sorry. Okay. So vectors of this becomes 9V left. Now it's alright. Fine. Alright. Is it alright now? I just made a calculation mistake. I've rectified it. Okay. And VD1G. So now this is alright. Fine. VD1P, velocity of D1 with respect to plank. Okay. 3V right. That's fine. And velocity of center with respect to plank, that is just 9V left. Now this is alright. I just made a calculation mistake. I've rectified it. Okay. See, error is human. So mistake, someone commits. I've rectified it. So you just please bear it. Okay. So VD1P is 3V right and VCG is 9V left. Now we also have to determine the omega of drum with respect to plank. Now for that we use the vector relation for angular velocity. So omega dg, angular velocity of drum with respect to ground, is equal to omega velocity of drum with respect to plank plus angular velocity of plank with respect to ground. But the plank translates with respect to ground. It has no rotation. So no rotation, so no angular velocity. So omega pg becomes 0. So omega dp, that is angular velocity of drum with respect to plank, omega dp is same as angular velocity of drum with respect to ground, that is omega dg. Now omega dg we determined in the previous part of the question. Omega dg was determined to be how much? By from relative normal speed by separation 10v plus 2v by r. So that was determined to be 12V by R. This was omega, and this omega was shown to be in anti-clockwise sense. So omega dp is also 12V by R in anti-clockwise sense. Alright, this much calculation we have done. Now we will determine the IC of drum with respect to Planck by different methods. Alright, we will determine the IC of drum with respect to Planck by several different methods. First I write method 1. Alright, now what I do first, I draw the line C here, I draw the line D1 here. Now with respect to Planck, center C is moving towards left. At what left? What speed? 9V left, as I determined here. And D1 is moving rightward with respect to Planck. At what speed? 3V right. Okay. And C is moving leftward at 9V. All these velocities are with respect to Planck. Now you can again see, since directions of velocities of C and D1 are opposite, so IC of drum with respect to Planck will lie somewhere on the line segment joining C and D1, anywhere between these 2 points. Again you can explain it why. Suppose we take a point P here, say at a distance of y2. I just write y, okay. I take a point P here at a distance y below center. Now we apply a SRC procedure for velocity between C and P in the frame of Planck. So we write SP arrow C and OP arrow D1, OP arrow P. Okay. Now what I do, I give the velocity of selected point C to other point P. So this is C, this is P. To P I give a velocity what? 9V. Then omega, I set the omega sentence. P moves in anti-clockwise sense with center at C and radius y. So to point P you get a velocity of omega dp into y. Omega dp is same as 12V by R. That is equal to omega y. Okay. This distance y was taken to y. Now by combination method, velocity Vp becomes omega y minus 9V. Now in this case y varies from 0 to R. Now see, Vp is a linear function of y. That is, Vp is a continuous function of y. Vp is a continuous function of y. Okay, fine. So this is a bit, okay. So now see, when y is 0, Vp is equal to how much? Minus 9V, negative. And when y is equal to R, then when y is equal to R, implies Vp becomes what? Omega is what? 12V by R, as I determined just now, into R minus what? 9V. That is, it becomes 3V, which is positive quantity. So when y equal to 0, Vp is negative. And when y is equal to plus R, Vp is positive. And Vp is a continuous function of y. So from the intermediate value theorem of calculus, there exists a point P lying between C and D1 such that Vp becomes 0. And by definition, that is the location of IC. So P has to be the IC. So since P is the IC, therefore, what we do, so this we have proved that IC lies between C and D1. Alright, this I have already proved now by this method. I hope it is clear. It's simply the intermediate value theorem of calculus. Y equal to fx is a continuous function of x in the interval a comma b. And fa and fb have opposite signs. Then there exists a value of x in the lying in the open interval a comma b such that fx equal to 0. The same concept has been used here also. So now we solve this by method 1. So angular velocity of drum with respect to Planck is same as omega of drum with respect to ground, that is just omega in anti-clockwise sense, 12V by R, which we have determined. Now by method 1 I solve this. The velocity of center C with respect to Planck is how much? 9V. 9V is equal to omega into y, where omega is equal to 12V by R. Okay, fine. Omega equal to how much? 12V by R. Okay. And P1 is at a distance of how much? IC is a distance of D1 from ICP is equal to R minus Y. The speed of this is 3V. Omega into R minus Y. Now I divide these two, this by this. 9V by 3V becomes 3. Omega cancels out. y by r minus y. 3r minus 3y is equal to y. So y is equal to 3r by 4. This is the required answer. I see of drum with respect to plank is at a distance of 3r by 4 below center C. So I see of drum with respect to plank is at a distance of 3r by 4 below center C, which we obtained by method 1. Okay. Now method 2. See, in method 1 we wrote two equations, these two. In method 2 we can determine omega, which we already determined, and apply substitute the value of omega in any one of these two equations. Suppose I substitute the value of omega in this equation. So 9v equal to omega we have determined to be how much? 12v by r into y. Now v cancels out. So y becomes how much? 9r by 12. That is how much? 3r by 4, which is same answer. Okay, fine. Alright. I hope it is fine. Now, third method. I use that concept. IC of drum with respect to plank is at a distance of VCP by omega dp from C along the vector omega dp cross VCP. This concept I use. Alright, fine. Now this side of it, okay. So this distance is how much? VCP by omega dp. Now VCP we have determined to be how much? 9v left. Omega dp is same as omega dg, which is 12v by r. So this becomes 3r by 4. Now in direction omega dp cross VCP. Now omega dp, since omega dp is anti-clockwise, so its direction is dot outward. And VCP is 9v left. So omega dp is outward, 9v is left. Omega dp outward, VCP left. Omega cross VDP by rule of cross product becomes in downward direction. So IC of drum with respect to plank is at a distance of 3r by 4 below C. Same answer we have obtained again. Okay. Now I solve this by method 4. Okay. I solve this question by method 4. I solve this question. Method 4. IC of drum with respect to plank is at a distance of V d1p by omega dp from d1 along the vector omega dp cross V d1p. Omega dp cross V d1p. So now we determine this quantity on V d1p by omega dp. V d1p as we have determined is how much? 3v, right? And omega dp is same as omega dg, which is 12v by r. This becomes simply r by 4 along the direction omega dp cross V d1p. Now omega dp, since omega dp is anti-clockwise, so its direction is dot, normally outward of the plane of the board, and V d1p is rightward. Omega dp is outward, Vdp is that side. So if you take the cross product, direction is upward. So IC of drum with respect to plank is at a distance of r by 4 vertically above d1. That is at a distance of r minus r by 4 vertically below C. That is 3r by 4 below C. So same answer we have obtained again. I hope it is clear. This is r by 4 above d1. So below C, how much distance? R minus r by 4. That is 3r by 4 below center C. 3r by 4 below center C. That is the IC of drum with respect to plank. So by 4 different methods, this problem has been fully solved. I hope you have understood it very nicely. There's no doubt. Okay. So So you go through these. If you are able to solve these problems, you'll be able to solve most of the problems in JEE Mains and Advanced. There's no doubt about it. You'll be able to solve it, I'm sure. Okay. In case you have one or two doubt, you just write in the comment box. I just look into it. Fine. So this I close it here. And next session also I'll take up some more problems on rigid body kinematics related to IC calculation by line drawing method. Okay. So this I close it here. Fine. All right.